The moon may look calm and silent in the night sky, but it holds mind-blowing realities that continue to astonish scientists and believers alike. Because this glowing companion of Earth is not just a beautiful object, but a dynamic world with measurable influence over our planet and deep resonance within human history and faith. One scientifically proven fact is that the moon is slowly moving away from Earth at a rate of about 3.8 centimeters every year, a measurement confirmed by laser reflectors placed on its surface during the Apollo missions. Scientists bounce laser beams off these reflectors and calculate the exact distance with extreme precision, proving that the Earth-Moon system is not static but gradually evolving. This slow drifting affects Earth's rotation as well, making our days slightly longer over millions of years, a subtle but measurable change that demonstrates how closely connected our planet is to its satellite. Another astonishing reality is that the moon stabilizes Earth's axial tilt, which is the reason we experience relatively stable seasons. Without the moon's gravitational pull, Earth's tilt could wobble chaotically, causing extreme climate shifts that might make complex life difficult or even impossible. And this stabilizing role highlights how finely balanced our planetary system is. The moon's gravitational force is also responsible for ocean tides, and this is not a small effect, but a powerful rhythmic motion of entire oceans rising and falling twice a day. Tides influence marine ecosystems, coastal environments, and even the long-term evolution of life, since early tidal pools may have provided conditions that helped the first life forms transition from water to land. The moon is about 4.5 billion years old, nearly as old as Earth itself, and the leading scientific theory, supported by isotopic evidence from lunar rocks, suggests it formed after a Mars-sized body collided with the early Earth, ejecting material that eventually coalesced into the moon. This giant impact hypothesis explains why lunar rocks share similarities with Earth's mantle while also having distinct differences. Despite appearing bright, the moon's surface is actually very dark, reflecting only about 12% of the sunlight that hits it, similar to worn asphalt, and its brightness in our sky is due to contrast against the darkness of space rather than high reflectivity. The moon has no atmosphere in the way Earth does, meaning there is no air to scatter light or soften shadows. This causes extreme temperature differences, ranging from about 127 degrees Celsius in sunlight to minus 173 degrees Celsius in darkness, conditions confirmed by direct measurements from lunar missions. Because there is no atmosphere, there's also no weather, no wind, and no erosion from water, which means footprints left by astronauts can remain for millions of years, an almost unimaginable concept compared to Earth where wind and rain quickly erase marks. Another extraordinary fact is that the moon is tidally locked with Earth, meaning it rotates on its axis in exactly the same time it takes to orbit Earth, about 27.3 days, which is why we always see the same face. This synchronous rotation is a result of gravitational interaction over millions of years and is fully explained by physics. Yet it continues to fascinate observers who realize that the so-called far side remained unseen by humans until space probes photographed it in the 20th century. The far side is not permanently dark, as many people once thought, but receives just as much sunlight as the near side. It simply faces away from Earth. The moon's surface is covered with craters formed by asteroid impacts, and because there is no atmosphere to burn up incoming meteoroids, even small objects strike the surface directly, creating new craters that scientists can observe and date. Some of the largest dark patches visible to the naked eye are called Maria, vast plains of basalt formed by ancient volcanic eruptions billions of years ago, proving that the moon was once geologically active, though today it is mostly inactive. Seismic instruments placed on the moon detected moonquakes, some caused by tidal stresses from Earth's gravity, showing that the moon is not completely dead internally, but still experiences subtle geological activity. One of the most mind-blowing measurements is that the moon's gravity is only about 1/6 that of Earth, meaning a person who weighs 60 kilograms on Earth would effectively weigh only 10 kilograms there, a fact confirmed during human missions when astronauts could leap higher and move in slow, bouncing strides. The moon also preserves a record of the early solar system. Because its surface changes so slowly, it acts like a time capsule, keeping evidence of ancient impacts that were erased from Earth by tectonic activity and erosion. Scientists have also confirmed the presence of water ice in permanently shadowed craters near the lunar poles, detected through spectroscopy and radar data, suggesting that even in such a harsh environment, frozen water can exist where sunlight never reaches. From an Islamic perspective, the moon is repeatedly described as a sign for humanity, and the Quran refers to the sun and the moon as calculated bodies moving in precise order, a statement that aligns remarkably with the scientifically measured orbital mechanics governing their motion. The Arabic term, often translated as calculated or precisely determined, reflects the predictable cycles that astronomers can compute centuries in advance. The lunar cycle, approximately 29.5 days from one new moon to the next, forms the basis of the Islamic calendar, demonstrating a direct connection between celestial mechanics and religious life. As months begin with the sighting of the crescent, a practice rooted in both observation and tradition traced back to Muhammad. The moon's phases are caused by its position relative to Earth, and the sun, not by Earth's shadow, except during a lunar eclipse. And this scientific explanation matches the observable pattern described in Islamic tradition, where the moon is said to pass through stages until it returns like an old curved stalk, a metaphor that beautifully reflects the thin crescent shape seen at the end of the lunar month. Another scientifically established phenomenon is the lunar eclipse, which occurs when Earth passes directly between the sun and the moon, casting its shadow on the lunar surface. During totality, the moon often appears red due to Earth's atmosphere bending and filtering sunlight, a process fully explained by optics and atmospheric physics. And Islamic teachings describe eclipses as signs of divine power rather than omens tied to human events, emphasizing reflection rather than superstition. The moon's gravitational pull even slightly deforms Earth's solid crust, not just its oceans, creating tiny bulges measurable by sensitive instruments, revealing that the interaction between Earth and moon penetrates deep into planetary structure. Over billions of years, the moon has helped slow Earth's rotation from a much faster spin in its early history to the 24-hour day we now experience, a gradual deceleration confirmed through geological and fossil records that show ancient days were shorter. Without the moon, nights on Earth would be far darker, affecting nocturnal ecosystems and human history alike, since moonlight has guided travelers, inspired poets, and structured agricultural practices across civilizations. Even the fact that the moon appears almost exactly the same size as the sun in our sky, allowing total solar eclipses to occur, is a temporary cosmic coincidence made possible by their relative distances and sizes, a geometry confirmed by precise measurement, and one that will not last forever as the moon continues to drift away. All of these scientifically proven realities reveal that the moon is not merely a decorative object, but a deeply influential partner in Earth's story, a celestial body whose measurable properties, gravitational effects, geological history, and precise orbital motion reflect a universe governed by consistent laws, inviting both scientific investigation and spiritual contemplation. Another astonishing and scientifically verified reality about the moon is that it significantly influences the length of Earth's day through a process called tidal friction, where the gravitational pull between Earth and the moon creates bulges in Earth's oceans that do not align perfectly with the moon's position due to Earth's rotation. This misalignment creates a torque that gradually slows Earth's spin while transferring angular momentum to the moon, pushing it slightly farther away, a phenomenon confirmed through atomic clock measurements and laser ranging experiments. Billions of years ago, Earth's day was only about 5 to 6 hours long, and fossil growth patterns in ancient corals and sediment layers reveal that there were more days in a year in the distant past, providing geological evidence that Earth's rotation has been slowing over immense timescales. The moon is also responsible for a phenomenon known as tidal locking, not only in itself, but in many other moons throughout the solar system. demonstrating that gravitational synchronization is a universal physical process governed by Newtonian mechanics and conservation of energy. Another mind-blowing fact is that the moon has a slightly egg-shaped orbit around Earth, meaning its distance varies between perigee when it is closest and apogee when it is farthest. This variation causes what is popularly called a supermoon, when the full moon coincides with perigee, making it appear slightly larger and brighter in the sky, a difference measurable by telescopes and imaging instruments. The moon's orbit is also inclined about 5 degrees relative to Earth's orbital plane around the sun, which is why eclipses do not occur every month. Only when the sun, Earth, and moon align at specific points called nodes do solar or lunar eclipses take place, a precision that astronomers can calculate years in advance using orbital mechanics. The surface gravity of the moon not only affects movement, but also changes how dust behaves. Lunar regolith, the fine powder covering its surface, is extremely sharp and abrasive because there is no wind or water to smooth the particles, a property discovered during human missions when the dust clung to spacesuits and equipment due to electrostatic charging from solar radiation. Another scientifically confirmed detail is that the moon has mass concentrations known as mascons, regions beneath large impact basins where denser material increases local gravity. These were detected by tracking the motion of orbiting spacecraft, which experience slight changes in velocity when passing over these areas, revealing hidden structures beneath the surface. The moon's core is relatively small compared to Earth's, making up only a tiny fraction of its total volume, and seismic data collected from instruments left on the surface show that it likely has a partially molten outer core, although its magnetic field today is extremely weak compared to Earth's global magnetic shield. Interestingly, lunar rocks show evidence that the moon once had a stronger magnetic field billions of years ago, indicating that it may have had a more active internal dynamo early in its history. The moon's far side differs significantly from the near side, with far fewer maria and a much thicker crust, a difference confirmed by spacecraft mapping and gravitational field measurements. Scientists believe this asymmetry may be linked to how heat was distributed during the moon's formation and early evolution. The moon's lack of atmosphere means that the sky from its surface would appear completely black even during daytime because there is no air to scatter sunlight, and stars would be visible even when the sun is shining, an observation confirmed by astronauts and unmanned missions. Sound cannot travel on the moon because there is no medium such as air to carry sound waves, meaning communication would require radio systems, a fact that emphasizes how fundamentally different that environment is from Earth. Another astonishing truth is that tiny meteorites continuously strike the moon, causing flashes of light that have been observed from Earth through telescopes, proving that the lunar surface is still being reshaped, though slowly, by ongoing impacts. The moon also experiences temperature expansion and contraction due to extreme heat differences, causing small cracks and shifts in rocks over time, further demonstrating that even without weather, physical processes still alter its surface. Scientifically, the moon plays a role in stabilizing Earth's climate over geological timescales, reducing chaotic variations in axial tilt that could otherwise cause extreme ice ages or dramatic warming periods. And climate models strongly support the idea that the presence of a large moon contributes to long-term environmental stability conducive to complex life. The moon's orbital period relative to the stars, called the sidereal month, differs slightly from its phase cycle relative to the sun, called the synodic month, because Earth itself is moving around the sun. This subtle distinction, measurable with precise observation, shows the complexity and harmony of celestial motion. From an Islamic perspective, the moon is described as a light that reflects illumination, distinct from the sun's blazing radiance, and modern science confirms that the moon does not produce its own light, but reflects sunlight from its surface, a fact established centuries after revelation through optical measurement and space exploration. The splitting of the moon is referenced in Islamic tradition, where it is described as a sign witnessed during the time of Muhammad, and while this event belongs to theological discussion rather than modern laboratory verification. The broader theme emphasizes that the moon itself is a created body subject to divine command and cosmic law. The precise predictability of lunar phases has allowed astronomers to construct detailed mathematical models that can forecast the exact time of a crescent appearance decades ahead, reinforcing the idea of order and calculation in the heavens. The moon's influence even extends to biological rhythms. Some marine species synchronize reproduction with lunar cycles, and studies have shown that certain coral spawning events are triggered by specific phases of moonlight intensity, demonstrating a measurable link between celestial mechanics and life on Earth. Even human cultures across continents independently developed lunar calendars, showing how deeply the moon's cycle is embedded in human civilization. The moon also slightly shields Earth from some asteroid impacts by acting as a gravitational attractor, drawing certain objects toward itself instead of allowing them to strike our planet. And its cratered surface stands as visible evidence of this protective role across billions of years. Modern missions have mapped the moon in extraordinary detail, revealing mountains, valleys, lava tubes, and polar craters that may one day support human exploration bases, and data from orbiters continue to refine our understanding of its composition and history. The realization that this familiar disk in the sky is a complex geological world, a gravitational stabilizer, a climate regulator, a timekeeper for religious practice, and a preserved record of early solar system history transforms our perception of it from a simple nightlight into a profound cosmic partner whose scientifically proven properties continue to inspire both research and reflection. One of the most astonishing scientifically proven facts about the moon is that it contains evidence of the earliest chapter of our solar system's history preserved almost untouched for billions of years. Because unlike Earth, which constantly reshapes its surface through plate tectonics, erosion, volcanic recycling, and ocean activity, the moon has no active plate tectonics and virtually no atmospheric weathering, allowing ancient impact scars to remain visible as a frozen record of cosmic events. Radiometric dating of lunar samples brought back by astronauts has confirmed ages exceeding 4 billion years, making some lunar rocks older than most rocks found on Earth's surface. These samples, analyzed in laboratories with isotopic precision, have helped scientists understand not only the moon's formation, but also the early bombardment period known as the Late Heavy Bombardment, a time when asteroids frequently collided with inner planets, shaping their surfaces in dramatic ways. Another mind-blowing reality is that the moon's presence may have directly influenced the emergence and evolution of life on Earth, because tidal forces created dynamic coastal environments where cycles of wetting and drying could have concentrated organic molecules, potentially aiding complex chemical reactions necessary for life's origin, and while life's exact beginnings remain under investigation. Laboratory simulations and geophysical models strongly support the importance of tidal energy in early biochemical evolution. The moon also affects Earth's rotation in subtle daily ways. As tides move across ocean basins, they redistribute mass, slightly altering Earth's moment of inertia and causing measurable microvariations in the planet's rotational speed, changes so precise that modern atomic clocks can detect them. Another scientifically verified fact is that the moon's gravitational pull contributes to a phenomenon called precession, a slow wobble in Earth's rotational axis that completes a cycle roughly every 26,000 years, influencing long-term climate patterns and the apparent position of stars over millennia, something ancient astronomers noticed, but only modern physics fully explained. The moon's regolith contains tiny glass beads formed by ancient volcanic fire fountains, discovered through microscopic analysis of returned samples, proving that the moon once had explosive volcanic activity driven by gases escaping molten rock, reshaping our earlier belief that lunar volcanism was entirely gentle and slow. In addition, recent orbital missions have detected traces of hydroxyl molecules across parts of the lunar surface, suggesting that interactions between solar wind hydrogen and oxygen in lunar minerals can create temporary water-related compounds, demonstrating that even in an airless environment, chemical processes are continuously occurring. The moon's polar regions are especially fascinating because some craters there have not seen sunlight for billions of years due to the moon's small axial tilt, creating permanently shadowed regions where temperatures remain extremely low, cold enough to trap water ice delivered by comets or formed through chemical reactions. Spectrometers and neutron detectors aboard orbiters have confirmed the presence of this ice, raising the possibility of future human use for drinking water and fuel production. Another incredible fact is that Earth and the Moon orbit a common center of mass called the barycenter, which lies inside Earth but not at its exact center, meaning Earth itself performs a subtle wobbling motion as both bodies dance around this invisible point, a motion confirmed by gravitational calculations and astronomical observation. The Moon also exerts tidal forces on Earth's atmosphere, not just its oceans, producing atmospheric tides that influence wind patterns in subtle but measurable ways. The very existence of the Moon at its relatively large size compared to its host planet is unusual when compared with other rocky planets in our solar system, as most planetary moons are either much smaller relative to their planets or formed through different capture processes. This unusual size ratio strengthens the giant impact formation theory supported by isotopic similarities between lunar and terrestrial rocks. Another scientifically established observation is that when astronauts placed seismometers on the Moon, they discovered that moonquakes can last much longer than earthquakes because the Moon's dry, rigid structure transmits vibrations differently, allowing seismic waves to reverberate for extended periods. The Moon's surface gravity also influences how impacts occur. Because gravity is weaker, ejecta from asteroid collisions can travel much farther, creating ray systems that stretch across vast distances, visible even from Earth through telescopes. The Moon's brightness varies slightly depending on its angle relative to Earth and the Sun, a phenomenon called the opposition surge, where it appears brighter when fully illuminated due to reduced shadowing between regolith particles, a behavior confirmed through photometric analysis. From an Islamic perspective, the Moon is repeatedly described as a sign among the signs of creation, functioning with precision and order, and the emphasis on its calculated phases corresponds with the measurable regularity that astronomers have documented with mathematical accuracy. The lunar month, averaging about 29.53 days, is so consistent that deviations can be predicted centuries ahead using celestial mechanics. The sighting of the crescent to mark months in Islamic practice demonstrates a direct engagement with observable astronomy, connecting spiritual life to the physical motions of celestial bodies in a way that encourages reflection upon natural order. The Moon's eclipses, fully explained by orbital alignment geometry, were addressed in Islamic teachings as events prompting prayer and contemplation rather than fear, aligning with the scientific understanding that eclipses occur due to predictable cosmic positioning rather than supernatural chaos. The Moon also contributes to Earth's long-term habitability by moderating axial tilt variations, which climate simulations show could otherwise swing dramatically, potentially leading to severe ice ages or intense warming cycles that might destabilize ecosystems. Even the fact that total solar eclipses are possible because the Moon's apparent size nearly matches that of the Sun in our sky is a geometric outcome of distance and diameter ratios that can be measured precisely. This near-perfect alignment allows scientists to study the Sun's corona during eclipses, leading to discoveries about solar structure and plasma behavior. Another fascinating truth is that the Moon contains lava tubes, underground tunnels formed by flowing basaltic lava billions of years ago, detected through radar imaging and gravitational mapping. These structures may provide natural shielding from radiation for future explorers. The Moon's lack of global magnetic protection means its surface is directly exposed to solar wind and cosmic radiation, causing gradual implantation of charged particles into the soil, altering its chemical composition over time. The Moon also acts as a calibrator for astronomical distance measurement, because its distance can be measured directly with laser ranging, providing a benchmark that helps refine models of gravitational theory, including tests of aspects of general relativity through precise tracking of orbital behavior. Over immense timescales, computer simulations predict that the moon will continue to drift away until total solar eclipses are no longer possible, transforming the visual relationship between sun and moon in Earth's sky. The simple act of looking at the moon connects observers to a body whose motion can be expressed in equations, whose rocks carry isotopic signatures of ancient collisions, whose gravity shapes oceans and climate, and whose phases structure religious calendars and cultural life. This combination of measurable physical influence and enduring spiritual symbolism makes the moon one of the most extraordinary objects visible to the human eye, a celestial companion whose scientifically proven properties continue to deepen our understanding of the universe while inviting contemplation of order, balance, and purpose in creation. Another astonishing and scientifically verified fact about the moon is that its formation likely changed the chemical structure of Earth in profound ways, because the giant impact that created it would have melted large portions of the early Earth, allowing heavier elements like iron to sink toward the core, while lighter materials rose toward the crust. A differentiation process confirmed by geochemical modeling and isotopic comparisons between terrestrial and lunar rocks. Without this event, Earth's internal layering and magnetic field might have developed differently, potentially altering conditions necessary for long-term habitability. The moon also plays a measurable role in stabilizing Earth's obliquity or axial tilt, which currently varies only slightly between about 22.1 and 24.5 degrees over a 41,000-year cycle, and climate simulations show that without a large moon, gravitational interactions with other planets could cause chaotic tilt variations ranging far more widely, possibly leading to extreme climate swings that would challenge complex ecosystems. The moon's gravitational influence extends beyond tides and tilt, as it contributes to the phenomenon of nutation, a small oscillation superimposed on Earth's precession, detectable with high-precision astronomical instruments and essential for accurate celestial navigation and satellite positioning systems. Another mind-blowing reality is that the moon's surface contains vast impact basins, such as the South Pole Aitken Basin, one of the largest known impact structures in the entire solar system, stretching roughly 2,500 kilometers in diameter, and orbital measurements of its composition suggest that the impact may have excavated material from deep within the lunar mantle, giving scientists rare insight into the moon's internal structure. The moon's crust on the near side averages about 30 to 40 kilometers thick, while on the far side it can exceed 70 kilometers, a difference mapped by gravitational and seismic data, helping researchers understand asymmetrical heat flow during its early molten stage. Another scientifically established observation is that the moon experiences a phenomenon called libration, a slight oscillating motion that allows observers on Earth to see about 59% of its surface over time rather than exactly half. This effect results from the combined influence of orbital eccentricity and axial tilt and can be predicted precisely through celestial mechanics. The moon's regolith contains implanted particles from the solar wind, including hydrogen and helium isotopes, which serve as a historical archive of solar activity over billions of years, something impossible to preserve on Earth due to atmospheric shielding and geological recycling. Among these particles is helium-3, a rare isotope that some scientists consider a potential future fusion fuel. And while practical fusion energy remains technologically challenging, the confirmed presence of helium-3 in lunar soil demonstrates how the moon acts as a collector of solar material. The absence of atmospheric pressure on the moon means that liquid water cannot remain stable on its surface under normal conditions, instantly boiling or freezing in sunlight or shadow, a physical consequence confirmed through thermodynamic principles and direct measurements from landers. Another remarkable fact is that when the moon passes directly overhead, its gravitational pull slightly reduces your effective weight by a tiny fraction, measurable only with extremely sensitive instruments, but fully predictable through Newton's law of universal gravitation. The moon also influences the length of Earth seasons over tens of thousands of years through gravitational interactions that contribute to Milankovitch cycles, which are linked to the advance and retreat of ice ages documented in ice core and sediment records. From an Islamic perspective, the moon is described as following a determined course, and this reflects the precisely calculable orbital path that modern astronomy can model using gravitational equations refined since the time of Isaac Newton and later expanded by Albert Einstein through general relativity, both of which accurately predict lunar motion to extraordinary precision when corrected for relativistic effects. The regularity of lunar phases, which guide the Islamic calendar, demonstrates the harmony between observable celestial mechanics and spiritual observance, as believers rely on the consistent cycle of waxing and waning crescents that astronomy can forecast centuries in advance. The moon's eclipses, once feared in many ancient cultures, are fully understood today as predictable alignments, and Islamic teachings emphasize that such events are signs encouraging humility and reflection rather than superstition, aligning contemplation with natural law. Another astonishing scientific fact is that the moon's surface has been mapped to resolutions of mere meters by orbiting spacecraft, revealing intricate geological features such as rills, domes, and collapsed lava tubes that provide clues about its volcanic past. Some of these lava tubes may be hundreds of meters wide and kilometers long, potentially offering natural radiation shielding for future human settlements, as radiation levels on the lunar surface are significantly higher than on Earth due to the absence of a thick atmosphere and global magnetic field. The moon's albedo, or reflectivity, slightly changes depending on the angle of illumination, and precise photometric studies show how microscopic surface texture influences brightness, enabling scientists to better interpret data from other airless bodies like asteroids. Another mind-blowing measurement is that Earth's oceans respond almost instantly to the moon's gravitational pull, creating tidal bulges that move as Earth rotates. Yet friction with continental boundaries delays the peaks, demonstrating the complex interaction between celestial mechanics and planetary geography. The moon also acts as a natural laboratory for studying impact physics because its preserved craters allow scientists to estimate impact rates and model potential asteroid threats to Earth. The relative scarcity of atmosphere means that when sunlight strikes the lunar surface, there is no scattering to create twilight. The transition from day to night is abrupt, a sharp boundary called the terminator, which can be observed moving across the moon's face from Earth. The moon's small axial tilt, about 1.5 degrees, explains why it does not experience seasons like Earth does, and this near-upright orientation results in polar craters that remain permanently shadowed, preserving ancient ice deposits confirmed through spectroscopy. Another fascinating fact is that the moon's gravitational interaction slightly stabilizes Earth's rotation against chaotic resonance effects caused by other planets, reinforcing the long-term predictability of our day-night cycle. The moon's distance is such that radio signals take about 1.3 seconds to travel one way between Earth and the lunar surface, a measurable delay experienced during communications with astronauts and robotic missions, reminding us that even our nearest celestial neighbor is separated by vast emptiness. The moon has no global weather system, yet it does experience electrostatic dust levitation, where fine particles can become electrically charged by solar ultraviolet radiation and rise slightly above the surface, a phenomenon observed indirectly through horizon glow. Detected by spacecraft. The moon's existence also allows scientists to test gravitational theories by measuring minute deviations in its orbit, and decades of laser-ranging experiments continue to confirm predictions of gravitational physics with astonishing accuracy. All these scientifically proven realities reveal that the moon is not a silent, inactive rock, but a dynamic participant in Earth's story, shaping tides, stabilizing climate, preserving cosmic history, guiding calendars, and reflecting sunlight in measured cycles that invite both scientific exploration and spiritual reflection, demonstrating a harmony between observable physical law and the deeper meaning many find in the ordered structure of the universe. Another scientifically established fact about the moon is that its average distance from Earth is about 384,400 kilometers, a value measured with centimeter-level precision using laser ranging experiments. And this precise measurement has allowed scientists to refine models of gravitational interaction and orbital evolution with extraordinary accuracy. The Moon completes one orbit around Earth in about 27.3 days relative to distant stars. Its full phase cycle takes about 29.5 days because Earth itself moves along its orbit around the Sun, a subtle but measurable difference that reveals the layered complexity of celestial motion. The Moon's orbit is gradually becoming more circular over immense timescales due to tidal interactions, and this slow orbital evolution is fully consistent with conservation of angular momentum and gravitational physics. One of the most remarkable verified discoveries is that the Moon once possessed widespread molten rock oceans early in its history, often referred to as a lunar magma ocean. And as this molten layer cooled, lighter minerals floated upward to form the crust while denser materials sank, a process confirmed through analysis of anorthosite rocks collected during missions. The Moon's crust is rich in oxygen, bound within minerals, meaning that although there is no breathable air, oxygen atoms are abundant in solid form. And researchers have demonstrated experimentally that oxygen can be extracted from lunar regolith through chemical processes, suggesting potential resource use for future exploration. The Moon's gravity is strong enough to retain a very thin and temporary exosphere composed of trace gases like argon, helium, sodium, and potassium, detected through spectroscopic measurements. Yet this exosphere is so sparse that atoms rarely collide, making it fundamentally different from Earth's atmosphere. Another astonishing fact is that the Moon slightly shields Earth from variations in axial tilt caused by gravitational resonances with massive planets like Jupiter, whose influence on the inner solar system is significant, and simulations show that without lunar stabilization, Earth's tilt might vary chaotically over millions of years. The Moon's tidal forces also influence groundwater levels in certain coastal aquifers, measurable through sensitive instruments that detect periodic fluctuations synchronized with lunar phases. Scientifically, the Moon has served as a calibration target for telescopes and optical instruments because its surface reflectance properties are well studied, allowing astronomers to standardize measurements of brightness and contrast when observing other celestial bodies. The Moon's surface features mountain ranges formed by massive impacts, some peaks rising over 5 kilometers high, and because there is no erosion from wind or water, these mountains retain sharp profiles for billions of years. The Moon also exhibits thermal inertia differences across its terrain, meaning that rocky regions and fine dust cool and heat at different rates, a property measured by infrared instruments and used to infer surface composition. Another fascinating and verified phenomenon is Earthshine, where sunlight reflected off Earth faintly illuminates the dark portion of the crescent moon, a visible reminder that Earth itself acts as a reflector in the Earth-Moon system. The Moon's gravitational pull contributes to the slight deformation of Earth's shape, stretching it by several centimeters along the Earth-Moon axis, a measurable effect detected through geodetic monitoring. The Moon's orbit intersects with Earth's magnetotail during certain phases, exposing it to varying plasma environments that alter surface charging, a process studied through space probes and particle detectors. The Moon has no global plate tectonics, yet it does have tectonic features such as thrust faults formed as its interior cooled and contracted, causing the surface to wrinkle slightly, evidence captured in high-resolution imagery. The cooling and contraction of the Moon over billions of years has reduced its volume, creating scarps visible from orbit, confirming that even seemingly inactive bodies continue to evolve slowly. Another verified fact is that micrometeorite impacts constantly churn the lunar soil in a process called gardening, gradually mixing surface material over time and affecting the distribution of solar wind particles embedded in the regolith. The Moon's far side hosts a thicker crust and fewer volcanic plains, likely due to uneven heating and tidal locking early in its history, a theory supported by gravitational mapping missions. The Moon's influence extends to Earth's biological rhythms beyond marine life, as certain animal behaviors correlate statistically with lunar illumination levels, though mechanisms are still under study. The moon's orbital plane slowly rotates over an 18.6-year cycle known as the nodal precession, affecting the maximum and minimum tidal ranges on Earth, a pattern confirmed through long-term tidal records. The gravitational relationship between Earth and the moon also slightly affects satellite orbits, requiring engineers to account for lunar perturbations when calculating long-term trajectories. Another astonishing reality is that the moon's existence increases the likelihood of total solar eclipses visible from Earth's surface, events that have enabled scientists to study the sun's outer atmosphere and confirm aspects of gravitational light bending predicted by relativity. The moon's surface preserves records of solar radiation exposure in rock layers, helping scientists reconstruct ancient solar activity cycles. The temperature difference between lunar day and night causes rocks to expand and contract repeatedly, leading to gradual mechanical breakdown even in the absence of atmosphere, a process confirmed through experimental modeling. The moon's weak gravity allows volcanic gases in its early history to escape more easily into space, explaining why it could not retain a thick atmosphere like Earth. From an Islamic perspective, the moon is described as one of the signs placed in the heavens with measured phases for humanity to mark time, and this aligns precisely with the astronomical fact that its synodic cycle is regular and predictable, forming the basis of a calendar system that has remained consistent for over 14 centuries. The observation-based beginning of lunar months emphasizes direct engagement with the sky, reinforcing a relationship between human awareness and cosmic order. Eclipses, which are fully explained through orbital alignment, are treated in Islamic teachings as moments for prayer and reflection, harmonizing spiritual response with natural phenomena rather than attributing them to superstition. The moon's reflected light has historically enabled nighttime travel and agricultural planning, and scientifically this illumination level varies systematically according to phase angle and surface reflectivity. The moon also slightly affects Earth's rotation axis stability over extremely long timescales, contributing to the predictability that allows precise astronomical calculation. Even today, continuous laser ranging experiments refine our understanding of gravitational constants, and the moon remains central to testing physical theories. Its preserved craters reveal the intensity of early solar system impacts, offering insight into Earth's own erased history. The moon's existence may also reduce the frequency of catastrophic asteroid strikes on Earth by intercepting some objects, as evidenced by its heavily cratered surface. Over billions of years into the future, the moon will continue to drift away until Earth's rotation and the moon's orbital period become synchronized in a distant tidal locking state, though this lies far beyond current human timescales. The moon stands as a scientifically measured, gravitationally influential, geologically revealing, and rhythmically precise celestial body whose properties have been confirmed through observation, experimentation, sample analysis, and mathematical modeling, while its consistent cycles and visible presence continue to inspire reflection within Islamic thought as a sign of order, balance, and deliberate design in the cosmos, uniting measurable physical law with enduring spiritual meaning in a way few other objects in the night sky can achieve. When we bring together all these scientifically verified realities, the moon transforms from a simple glowing disk in the night sky into one of the most extraordinary and influential objects in our cosmic neighborhood, because every measurement, every rock sample, every laser pulse reflected from its surface confirms that it is deeply woven into Earth's past, present, and future. Its gravitational pull shapes the oceans, stabilizes Earth's axial tilt, moderates long-term climate patterns, subtly slows our planet's rotation, and even affects microscopic biological rhythms, demonstrating that its influence is not symbolic, but physically measurable and mathematically predictable. Its surface preserves a 4 billion-year record of asteroid impacts and early solar system history that Earth itself can no longer display due to erosion and tectonic recycling, making the moon a time capsule that helps scientists reconstruct the story of planetary formation. The evidence supporting the giant impact origin, confirmed through isotopic similarities between lunar and terrestrial rocks, reveals that the moon's birth was not a minor event, but a defining moment that shaped Earth's internal structure and long-term habitability. Its tidally locked rotation, its precisely calculable phases, its role in eclipses, and its gradual outward drift all demonstrate that it operates under consistent physical laws that can be described through gravitational equations refined over centuries of scientific discovery. The presence of water ice in permanently shadowed craters, the detection of moonquakes, the mapping of mascons, the study of lunar magma oceans, and the continuous micrometeorite impacts all prove that the moon, though quiet, is not lifeless in a geological sense, but continues to evolve slowly through natural processes. Even subtle effects, such as Earth's crustal deformation, atmospheric tides, nodal precession, and orbital perturbations reveal a dynamic Earth-Moon partnership that operates with extraordinary precision. From a broader perspective, the moon's size relative to Earth is unusual among rocky planets, and computer simulations suggest that without it, Earth's tilt might vary chaotically, potentially destabilizing climates necessary for complex life, meaning that this celestial companion may have quietly played a role in making Earth biologically rich and environmentally stable over billions of years. Its reflected light has guided travelers, shaped calendars, inspired civilizations, and structured time-keeping systems based on its 29.5-day synodic cycle, a rhythm so regular that it can be predicted centuries in advance with exact astronomical calculation. Within Islamic understanding, the moon is repeatedly described as a sign moving in a determined course, and modern astronomy confirms that its orbit, phases, and eclipses follow precise, measurable patterns governed by universal laws. The use of the lunar cycle in the Islamic calendar connects worship and daily life directly to observable celestial motion, reinforcing awareness of cosmic order through regular observation of the crescent. Eclipses, fully explained by orbital alignment, are approached in Islamic teaching as moments of humility and reflection, aligning spiritual consciousness with natural phenomena rather than superstition. The harmony between measurable physical law and spiritual reflection becomes especially powerful when one realizes that the same moon influencing ocean tides and axial stability is also the moon marking months of fasting and pilgrimage, uniting gravitational physics with lived human experience. Scientific exploration has not diminished the moon's significance. Instead, it has expanded it, revealing that beneath its quiet glow lies a body whose composition, motion, and history are interconnected with Earth at every level. Its distance can be measured as centimeters, its rocks dated to billions of years, its orbit predicted far into the future, and its gravitational influence calculated with extraordinary precision. Yet its presence still evokes wonder across cultures and generations. Ultimately, the moon stands as a bridge between observation and meaning, between equation and reflection, between measurable force and spiritual awareness, demonstrating that the universe operates with order, balance, and continuity. The more deeply science studies the moon, the clearer it becomes that this familiar companion is not accidental in its effects, but central to Earth's story, a stabilizer, a recorder of cosmic history, a regulator of natural rhythms, and a luminous sign in the sky that continues to invite both investigation and contemplation, reminding humanity that the heavens above are structured with precision while remaining a source of awe, gratitude,